welcome on stage Dr. Larry Beaver. He is Vice President, Research and Development at RSC Bio Solutions, and Mr. Scott Kopsick, Regional Sales Director, McDermott Offshore Solutions. They will be speaking on the topic environmentally acceptable lubricants, EALs, and their use in offshore oil and gas applications.
Thank you very much.
Hello, Dr. Larry. The floor is yours.
Scott should be joining us shortly. I'll begin the introduction so we don't delay things further. A bit about our company. RSC Bio Solutions is part of a larger company that began 96 years ago this month, a family-owned company that has been a leader in many fields. Originally, many areas of cleaning and lubrication. Our RSC Bio Solutions division specializes in EALs, environmentally acceptable lubricants, and VGP compliant products, such as hydraulic fluids, gear oils, and greases. Our core product lines are hydraulic fluids. The Futera hydraulic fluid line is the premier product in the line. It's an HEPR type hydraulic fluid. I'll talk about that momentarily. We also have a series of gear oils, a variety of specialty fluids for everything from ROVs to saw guide oils. The ROV fluids, the wire rope lube, the gear oils, greases, and hydraulic fluids are the ones most applicable to the LNG industry. And now I'll turn it over to Scott to talk a bit about our relationship.
Yeah, thanks, Larry. And thank you, everyone, for the forum today. So I'll talk a little bit of brief history about McDermott Offshore. McDermott Offshore is part of a small division of McDermott Incorporated, which is a very large chemical company. About 40 years ago, McDermott, which at that time was under other brand names such as Marston Bentley or W. Canning, McDermott finally bought those companies, and now we're McDermott Offshore. But basically, we have a water-based chemistries, water-based technologies for subsea applications. So really looking at opportunities to operate subsea valves and also have that footprint in the BOP control markets as well. So we have two known name brands, Oceanic and Pelagic in the offshore production market, and the Aerofon products in the drilling and exploration markets for BOP control systems. Now, the technology is kind of, well, it's a green technology. I like to look at it as, one of the first green technologies that was, we kind of used offshore. For one, it was non-flammable. It has excellent wear, lubrication and corrosion and micro protection. And of course, it's fit for discharge offshore, so it has to be non-toxic and a high degree of biodegradation. And of course, it has to work in all the major OEM equipment offshore. So again, we've been around since 1979 with that product. Our footprint is pretty broad. I like to think we're really anywhere that there's offshore oil and gas production and exploration. We have four major offshore facilities, or not offshore facilities, four major plants where we manufacture products. And also with that, we look at other distribution houses where we have products. So the footprint for the availability and the R&D and manufacturing of our products is a very good footprint. So, with that, we look at today we're looking at a partnership with RSC Bio, and what makes sense is, we're looking at, how can we better service our constituents, our clients offshore. So we kind of looked at the synergies between the two products. One of them taking the expertise and what they have in environmental acceptable lubricants on the marine side, and taking our history with offshore and subsea and kind of merging those two together. What this allows us also to look at is, the products themselves. Again, looking at a greener space, we both have products that are really have low impact to the environment. They are very high performance products, so they work well with critical path components. And what we can enable them to do also is to look at the footprint where we are in the offshore oil and gas market and have the availability of their products for the market. So kind of looking at it in a retrospect is that we want to look at a one-stop opportunity for our clients to be able to have products on the subsea side as well as the top side applications. Which leads us really kind of into, why are we here today? Well, we want to look at opportunities in the LNG market, and we want to look at, because we look at the LNG market as a green technology. It's a clean burning fuel. It's more widely available now, and with all of the sustainability initiatives that we're seeing in the industry today, we want to find out, low carbon emissions. We have these alternative fuels, wind and hydrogen fuels coming on board. But we want to kind of look at where the EALs can fit in that sustainability initiative for our product line. And that is where I'm going to hand it off to Larry for him to go ahead and tell you a little bit about the products themselves.
Thanks, Scott. It is risky. We're in the business of reducing risk to our customers. The metrics have changed. Anyone who's seen information in the news about the oil slicks surrounding cruise ships with cell phone cameras now, it doesn't take long for bad public relations over even a minor spill to wreak havoc for business. So our risk reduction does not involve compromise. We produce products, and McDermott produces products that do not compromise performance while actually reducing environmental risk. Scott, alluded to the partnership between us. This really is a sweet spot for both of us. Our only reason for existing at RSC Bio is for environmentally acceptable lubricants and VGP compliant products, such as our gear oils, greases, and hydraulic fluid. We're not this isn't a bolt-on to a mega company. This is our reason for being here. This is all that RSC Bio Solutions does. We have a whole list of potential applications for our products: stern tubes, crane hydraulics, davits, propellers, wire rope grease, gear oils and pump systems, thruster hydraulics, subsea control fluids, winch and wire rope hydraulics and greases, ROV launch and recovery system hydraulics, ring main hydraulics, and deck crane hydraulics. So we are prepared to supply VGP compliant, environmental acceptable lubricants in each of these arenas for your offshore applications. The strategy is it's not just choosing the right lubricant is part of the bigger mission. You want to reduce your total cost of ownership. You want to standardize globally, not buy this hydraulic from this supplier, this gear oil from another, this grease from a third. Ultimately, you want to increase uptime and build and protect your own brands, protect your public relations, and ultimately create a safe and more livable world, both by the product that you produce and the methods by which you produce it. So what is an EAL? You've heard us use the term, and it's an environmentally acceptable lubricant. Up until about 2015, there wasn't a really crystal clear definition. 2013, 2015 timeframe, the VGP was put into place. That's the Vessel General Permit that deals with vessels over 79 feet in length. And the EPA has set a fairly reasonable definition for what constitutes an EAL. It has to be readily biodegradable, meaning under EPA definition, greater than 60% biodegradability in 28 days. It has to be minimally toxic. And once again, there are a set of criteria within the VGP defining what that means. And it can't be bioaccumulative, which means it can't build up in the biosphere. It can't build up in the organisms. So we also consider renewability or the bio-based carbon content, as well as non-sheening characteristics, to be beneficial for our customers. So that kind of gives a groundwork to talk about what makes an EAL. And there's more than one type of EAL. The ISO standard recognizes 4 types of base oil, or 4 types of EALs based on their base oil composition. And I'm going to preface these comments about the different types of EALs by stating that these are general classifications. There are, I guess you would say, good and bad versions of each one of these, but I can talk about each of the base oil types and give you some guidelines as to which are the most suited for the LNG environment. The 4 types commonly found in the marketplace these are known by acronyms. The HE in each of these 4 stands for hydraulic fluid environmental. There's the triglyceride, the HETG, the HEPG, which is a polyalkylene glycol, often called a PAG. There are the HEES, which are synthetic esters. And then the last category is the HEPR, which is polyalpha olefin and other synthetic hydrocarbons. These 4 types of base oils are used in these 4 types of hydraulic fluid. This also crosses lines into gear oil and grease technologies as well. So there are readily biodegradable hydrocarbons used in greases in our lineup. And there are triglycerides used in greases in competing products. So you'll find, in general, triglycerides, synthetic esters, and the PAO-type hydrocarbons used for all 3 categories: gear oils, greases, and hydraulic fluids in one form or another. And how they differ in characteristics, the oxidation resistance of a fluid is basically a measure of its lifetime when exposed to oxygen. The water resistance deals with a product's ability to both separate water and be unaffected by water. Lubricity is fairly straightforward. It's the ability to lubricate surfaces, shown by things such as low wear and low friction. And then seal compatibility is important as well, because that gives you a feel for what kind of equipment you can put in it, or whether or not you can change to an EAL without making dramatic changes. And as you can see, there are advantages and disadvantages to some of these systems. The triglycerides are the least expensive, but they also have the poorest water resistance, and they aren't very oxidatively stable. So they are often used in things like ROVs, where the fluid is changed out frequently. Polyalkylene glycols can be very problematic because they aren't particularly miscible with other fluids, so you can't change them out very well with another kind of EAL. They don't typically have very good oxidation resistance, and they don't do well with a wide variety of seal types. The synthetic esters, also known as saturated esters, do quite well with lubricity. There are some seal issues with synthetic esters. They do tend to be hydrophilic or water-loving, so they don't always separate water very well, and they can be susceptible to hydrolysis and to oxidation. The category, the HEPR category, is the one that offers the characteristics most in common with the mineral oils that you want to replace in your system with EALs. Typically, the HEPR fluids, gear oils and greases, are the only category that can be considered drop-ins for existing mineral oil products. So how confident are we in this kind of HEPR technology? We've got more than 60,000 hours in the field. So this isn't just a lab exercise on our part. More than 60,000 hours in 6 years in closely monitored production vessels, in drill ships and positioning thrusters and hydraulic power units and in cranes. 10 years in the marine polar fleet in propulsion systems, in stern tube applications. And we already have multiple global OEM partners such as Transocean, Oceaneering, Diamond Offshore. So we have a lengthy field experience of more than 10 years with this technology to show that it is indeed a drop-in with mineral oil technology and can easily replace, allows you to easily replace existing mineral oil, gear oils, greases, and hydraulic fluids with an EAL with very little changeover issues, if any. This is an example of more than 6 years in a stern tube with virtually no change in viscosity, staying well within limits for an ISO 68 fluid. Now our job is protecting environments. All our EALs are designed to be biodegradable, minimal aquatic toxicity, no bioaccumulation, no sheen when spilled on the water. We also drive towards higher renewable content as new base oil technologies come forward, and our cleaners are neutral pH. And this goes across the line. Our Futerra hydraulic fluids, our Envirologic high performance hydraulic fluids, our Envirologic gear oils, and our Envirologic greases are all built with these 5 key characteristics in mind: the biodegradability, the minimal aquatic tox, no bioaccumulation, no sheen, and as high renewable content as we can put into the products. And we have eco-label certification for Futerra. Our triglyceride formula is bio-preferred, and all these products are VGP compliant. We offer superior technology that offers long-term value. You remember when I started, I talked about the goals, if you will, the strategy moving forward. Our products offer less lubricant consumption for longer changeout intervals. They reduce maintenance cost due to the longer maintenance intervals, and spills are treated more leniently when you have an issue with an EAL. It increases your uptime. They work with standard NBR seals, so you don't have to go in and replace your NBR seals with expensive FKM fluoroelastomer seals. They have excellent lubricating characteristics. And of course, your brand is important. There's less PR risk associated with using an EAL, even in applications where it is not mandated by law. You position yourself as a leader and an innovator by using an EAL.
Thanks, Larry. Again, the target here is, as this slide kind of shows, we're looking to be a provider of these environmentally acceptable lubricants and water-based hydraulic technologies for subsea applications as well as topside applications, and be able to not compromise any of the equipment performance and have a greener technology going forward. So again, we appreciate the time today to discuss some of this technology and see if there are some opportunities or at least some questions and interest about the technology in the LNG world, if you will. Thank you.
So thank you very much. Thank you, Dr. Larry. Thank you, Scott, for your presentation. We have a few questions for you. We have one from Brian Delamer. The question is, for topsides, are you looking at lubricants for prime movers like cat, Cummins, solar gas turbines, etc.?
Yes, we are. We don't do cylinder oils, if you will, but we do the hydraulics and the gear oils in these kind of systems.
Okay. Thank you. Scott, you wanted to add something?
No, I was just going to say, yeah, we'd definitely be interested in those. Again, the advantages are if you do have any kind of leaks, the environmental aspect of it is greatly minimized with this technology.
Great. So the person that asked Brian, he says that I will contact you. Thanks. Working in Hawaii, that's important.
Absolutely.
Okay, we need to go there. Check it out.
Yeah.
Yes, of course. So wait for a message from his side. I have a few questions as well. What makes RSC Bio EALs better than other EALs when it comes to water ingress?
Well,
take that one, Larry.
Yeah. A couple things. The HEPR technology we're using for marine applications is a very water rejecting product. It separates much more rapidly than competing EALs based on synthetic esters, for instance. I mentioned that esters are a bit hydrophilic, meaning that they will absorb more water than would an HEPR type system. So by absorbing less water and separating more quickly, oil water separator systems work more efficiently, and there is less opportunity for oxidation and hydrolysis that way.
Okay, and one last question. What applications do you see with your products in the LNG industry?
Let me take a stab at that one, Larry. I think a perfect example with the partnership between RSC and McDermott, a perfect example of this might be, say, an FLNG, which is a floating liquid natural gas and production facility. So they would actually be producing gas off the wells offshore while bringing it up topside, and then doing the LNG process, which is boiling it and transferring it to the LNG tankers afterwards. So we would be involved in the subsea aspect of it, where you are operating valve subsea, safety valve subsea, kind of the lifeblood of the subsea system, more or less. And then once we get to the topside world, we would look at the RSC Bio Solutions products in things such as cranes, launch and recovery systems for the subsea robotic systems, winches, wire rope greases, things like that. And then even really, if you kind of look at the offloading vessels, which is a transport vessel, the LNG tankers, if you will, they're going to probably have stern tubes in them, so they're going to be looking at utilizing that technology that RSC has there to keep the water ingress out of those systems. The separation of the water and the seawater or the oil and the seawater is very important, because it can really wreak havoc on those systems. But that would be a perfect example for me. Now, whether that exists or not, that's hopefully what we can find out some information today.
Yeah.
Okay.
That and positioning thrusters would be another real application for the RSC Bio products.
Absolutely.
Okay. So if you don't have anything to add to that, I want to thank you very much for your amazing presentation. Keep an eye for a message from Brian. And thank you once more.
Okay.
Thank you.
Thank you again for the opportunity, guys.
We appreciate it.
Thank
Thank you.